Today in geometry, we're looking at section 2.4, day 1, using postulates and diagrams. Our key questions: how can you identify postulates illustrated by a diagram? And what can and can't be assumed from the diagram? Tomorrow we will look at what we can and can't assume from the diagram. So today we're going to identify from diagram. So first let's talk about our postulates. Postulate number 5, if given 2 points, then exactly one line intersects them. Postulate 6, if given a line, then it contains at least 2 points. So that's just our definition of a line, really. Postulate 7, if 2 lines intersect, then their intersection is a point. We know a lot of this already that we learned in chapter 1. We're using what we learned in chapter 1 here. Postulate 8, if given 3 non-collinear points, then only one what contains them. Remember that 3 non-collinear points except a plane. Postulate 9, if given a plane, then the plane contains at least 3 non-collinear points. Postulate 10, if given 2 points in a plane, then the line containing them lies in the plane. And postulate 11, if 2 planes intersect, then their intersection is a line. Right, now we're going to look at a definition. Perpendicular figures. A line is perpendicular to a plane if and only if it is perpendicular to every line in the plane that intersects it at that point. So notice that I have these 2 planes here. They are intersecting. Notice we have this right angle marked here at the point A, where the lines are going through that. So from this picture, we see that line CE, so we could say that line CE is perpendicular, there's our symbol for perpendicular, remember, to plane. So line CE is vertical in plane T, so it's perpendicular to plane S. I can also say, because of that right angle, that line CE is perpendicular to line BD. Okay. All right, so let's look at some examples. Supply the postulate number demonstrated by the diagram. So if, what do I have here? If I have a plane, then I have 3 non-collinear points in it. So that is postulate number 9 from above. If given a plane, then the plane contains at least 3 non-collinear points. Number 2, if, so what do I have? I have 2 lines and they are intersecting. Then those 2 lines intersect at a point. So if given if 2 lines intersect, then their intersection is a point. That is postulate 7 from above. Okay, let's go to the back. If given 2 points, A and B, then one line contains those 2 points. Line AB, so this is postulate number 5. Number 4 says, if I have 3 non-collinear points, then they're contained in one plane. One plane makes those up. That's postulate 8. Postulate 5, if, look, I have 2 planes, okay, and they are intersecting, then they intersect at a line. That is postulate 11, tells us that. Number 6, if I have a plane that has 2 points, then now that line that contains those 2 points is in that plane. That is postulate 10. And finally, if I have a line, then I have 2 points on that line. So that is postulate 6. Great. So now it says, using the diagram, write an example of the postulate. This is the diagram down here in the corner that we're looking at. Okay. So A, it says, and we're going to write it in if-then form. So if given 3 non-collinear points, then only one plane contains them. Okay, so now I'm going to have to start out with if. So if given 3 non-collinear points, so I need to come down here and find 3 non-collinear points in this picture. I only have 3 points in this picture. That's A, B, and C. Remember, M and N are not points because they are not capital and they don't have a dot next to them. So if given points A, B, and C, so if given points A, B, and C, then plane. So what plane are A, B, and C in? Plane P. Then plane P contains them. So this is where we're just taking our postulate and we're making it specific to a diagram that they give me. Okay? All right. Let's look at B, postulate 5. Postulate 5 told us if given 2 points, then exactly one line intersects them. So I have to start out. If given points. So again, what line do I have over here in my picture that has 2 points on it? I have line AB. So if given points A and B, then line AB intersects them. Or I could say line AB contains them. Remember that our postulate 5 said if given 2 points, then exactly one line intersects them. So that's why I did that top one. Okay? But if you tell me that line AB contained them, that would be fine as well. Okay? All right, postulate number 7. If 2 lines intersect, then their intersection is a point. So what 2 lines do I have in this picture? Okay, so I have line AB and line M that are intersecting here. So if line AB and line M intersect, then they intersect at point. So what is the point where they intersect? A, at point A. Okay. So again, these are just giving specific examples from this diagram. We're taking those postulates. We know that if 2 lines intersect, their intersection is a point. So now looking at this specific diagram, taking that information and putting it in here. So instead of if 2 lines intersect, I have to name the 2 lines that intersect. Then they intersect at, I have to say what point they intersect at. Okay. All right. Last thing, we're going to review our LOD and our LOS. So remember, LOD, this is law of detachment. The rule says if a student is in Ms. Haskins' 7th hour class, then he or she is one of her Algebra 2 students. I teach 7th hour, Algebra 2. All right, so given Janelle is in Ms. Haskins' 7th hour, can we conclude anything by law of detachment? Yes, we can conclude that Janelle is an Algebra 2 student. So Janelle is an, and I'm just going to abbreviate Algebra 2 for A2 student. All right, same rule. If a student is in Ms. Haskins' 7th hour class, then he or she is one of her Algebra 2 students. Given Andrew is one of Ms. Haskins' students. Okay, can I come up to a conclusion? No, I cannot. My conclusion is none because maybe Andrew is a geometry student. We are not guaranteed that Andrew is an Algebra 2 student because it didn't tell me that he was in 7th hour. All right, so then remember LOS. This is our law of syllogism, also known as the chain rule. Okay, so the rule, if you pay more attention in geometry, then your understanding will go up. If your understanding goes up, then you will do better on your homework. If you do better on your homework, then you will do better on your tests. If you do better on your tests, then your grade will go up. If your grade goes up, then your GPA may go up. If your GPA goes up, then you may get more scholarships for college. The conclusion. So remember, we start with our very first if. If you pay more attention in geometry. If you pay more attention in geometry. Then, what was after our very last N, you may get more scholarships for college. You may get more more scholarships for college. On a side note, you will also make Ms. Haskin very happy. All right, so those were just a quick review of LOD and LOS. That is section 2.4, day 1, looking at postulates and diagrams and giving specific examples from postulates and diagrams.